So I got asked if I could build this table with crazy spirally legs. And today, I'm going to show you how I did it. Welcome to Werks. So when I first got the drawing for this table that I did not design, but I was asked if I could build it, the legs were the biggest mystery. And we needed to figure out a way that we could essentially turn a screw pattern around a wooden leg. Now, there are ways to do this by hand, but that's an awful lot of work, and the legs we were making were going to be out of white oak, so I thought for the amount of handwork that would be, it would be in my best interest to just try and come up with a jig. So I asked the question, how is a metal screw made? And the answer to that is with a metal lathe or a screw machine, and so I wanted to take the idea from a metal lathe and apply a similar apparatus into a wooden screw machine, if you will. So I started sketching some stuff in my notebook, and I came up with some gearing and some ratios on a jig that would basically turn the leg at one speed, and it would have a router travel up the entire jig at another speed, thus creating a screw. So I started machining some parts, and this first piece is just to hold this bearing in place. And once I got that the bearing seated in there, I could part that off. And this, you see the bearing has a little flange on it, so that can seat against a piece, and then this is kind of like a retaining ring to hold the bearing into place. You'll see what I mean here when I put it in a piece of wood. This is just to demonstrate how that little flange works. So that captures the bearing. So that's kind of the easiest piece of this whole puzzle. And then with that same block of aluminum, I wanted to turn a piece that would also use that same bearing. This is the other side of the bearing, goes into that, and that would hold a drive center from a wood lathe that would drive the actual leg. And then on the outside of this piece is going to be turned down for a sprocket like you'd see on a bicycle. And so here I'm tapping it to accept the drive center of the wood lathe. And you can see how the bearing fits on there and the drive center fits right in there. And that all worked out just great. So now I needed to turn the back side down so that I could have it accept the bike sprocket. And that fits on there just fine. Now I needed a way to fasten that sprocket to that mechanism. And so what I did was these holes that were on the sprocket, I ended up just tapping them. So I had to drill them out a little bit larger for the right size tap. And then I was able to use these cap screws, and that just kind of contained that machined part really nicely. Now these screws were a little bit long, but I was just really trying to make sure that my whole concept was going to work here. And then I got a piece of Acme thread. This is similar to the lead screw on a lathe, is basically what I'm making here. And I had to turn the end of this down so I could accept a different sprocket. And you see that little sprocket there. And that is just to get the ratio correct. I don't remember exactly what my ratios were here, but if anyone wants them, I'm happy to give them to you if you want to DM me on Instagram or put a comment down below. And so then I needed something to captivate that lead screw as well. I didn't need to put bearings on that. It's not going to be, super high load on this piece, so I kind of just made some bushings, and I used these pieces of aluminum and made some aluminum plates, and in the center I drilled a bigger hole that kind of captivates that whole lead screw. And the whole frame of this jig was going to be made out of wood, just out of plywood. And so I ripped up some scraps and started to build a box that will contain this whole apparatus. And I wanted to clamp everything in the same location on the front and back so that everything lined up nicely. So the hole I'm drilling right now, that smaller hole, is where the lead screw is actually going to go through. And that bigger hole is for the bearing. Now this is the back side. That smaller hole is going to be for essentially a tailstock, And I did end up having to size this up later. I made this way too small to start, but like I said, this is a prototype, so you live and you learn. And I actually drilled that hole in the wrong location. When I put my little mounting plates on there, that wasn't great. So I ended up relocating that. I brought it a little bit farther down. And then I just used a dado stack to put some dados into these pieces so everything would lock together. I didn't put any glue on this jig when I put it together because I knew there was a chance that I was going to have to take it apart and make some modifications if things didn't work out the way that they all worked out in my head. So here I'm actually putting it together, and this is that clip I showed earlier, that little bearing retaining part. And then I can screw the box together, and I just, like I said, I use some dados and then some pocket screws just to hold it all together. And that's nice and secure. And with the box made, I can feed the lead screw in. And that's what those little mounting plates were for. So that contains it on one side, and there's one of those mounting plates on both sides. So that completely contains the lead screw. And that's the back side that I'm putting it on now. And there's the kind of drive center with the sprocket. You can see there's the bearing flange on the back side. So that's kind of how that all captures itself. And then I could put that little sprocket onto the lead screw. And then I measured out a piece of chain to go around that. And this chain's always a bit of a pain to make the right size, but I got one of these little detachable links, so that makes it easier to take apart if you need to, and you can add or take off links with those. And they're still a little bit tricky. There's all kinds of tools that a bicycle shop will have to make those parts easier, but I don't have any of those because I don't really deal with that kind of stuff that often, and you can make it happen with just some pliers. And now I needed to make it essentially a carriage for a router to run up and down this jig. And so I started with this block of maple to run through the lead screw, and I needed to capture that, so when the lead screw turns, this whole thing will move up and down the carriage. And in doing so here, I drilled out I drilled out a bunch of material here so that those nuts would be captured inside of this this carriage piece. And then I chiseled it out so that the nuts would fit. And I did that on both sides, so there's two nuts there that capture that whole piece. And then I can thread that all through, and then that top plate is where the router will end up getting mounted to. So I can screw that down. And it's hard to tell, but there's some dados in that too that kind of lock it into the top, just to kind of keep that from rotating or moving or anything. And then I had a big hole there that the router bit would go through. And I put a couple screws into this piece of plywood to screw down the router base. On one of my test runs, I ended up running into a little bit of an issue here, so I ended up putting some actual bolts in that later, but I'll show that when we get there. And then I turned this little piece off camera. This is just a little piece of aluminum, and that just is kind of like a tensioner. It just keeps that chain aligned. And then I can kind of run it with a drill just to see how the whole thing is going to work. And for my testing here, everything seems like it's going to work just fine. So then here I am, I'm working in a different shop here actually. This is where I ended up building the table. This is up in my uncle's shop, and he's the one who designed this table. And I made a little tailstock to start, but it was way too small, so we ended up taking a bigger piece of threaded rod, and I didn't even show the little one because it wasn't really worth showing. But we took this big piece of 3/4 inch threaded rod and turned a big spike on it, and here you can see I'm drilling out that hole in the back side of this jig to accept that piece of threaded rod. And that piece of threaded rod is essentially making a tailstock like you'd have on a lathe. And I wanted to attach this piece of plywood to the bottom. That just kind of secures the whole thing. It keeps some of the dust inside of it, and I used an oversized piece of plywood so I would have some places to clamp it down to a bench, and that ended up working really well. And my little cross slide for the router itself was just a little bit too low, so I needed to carve out a little bit on the bottom, and I just ran it through the table saw a bunch of times to just create a little bit more clearance for the actual table legs. And you can see here how that all worked out just fine. And then I can reattach that, and then put the router base back on. And then I took some paste wax and waxed up the top because that's what the whole thing slides on, and I figured it would run a little bit better just with some wax. And so I made up these leg blanks out of white oak. I actually made 5 of these so that I could have one to just test this thing with and figure out everything that I needed to do. And to save a little bit time turning, I cut the corners down on these on the table saw. So I rotated the blade over to 45 and turned these squares essentially into octagons. But I couldn't run the whole length of the piece because the top of the table leg is still a square. So that top 4 or 5 inches stayed into a square, and then I can use a jigsaw to finish those cuts, and then I just found a hacksaw to cut the rest of that piece off. So you see how I'm kind of left with an octagon shape here, and then I can go over to the wood lathe and turn this round. Now there are a couple features in these legs too that I ended up turning before turning the spiral in. There's a little bit of a foot at the bottom and a kind of a round over at the top, just a bead profile that runs around the top and on the bottom. So I turned all those features in before going to the spiral jig. So it was still a little bit of prep to get it ready to actually turn the screw pattern into it. And I'm just checking my diameter here so I can have the same diameter go all the way up the leg and keep that as consistent as I could. And this is what I'm talking about on the top. We had this little bead profile, and then the same thing on the bottom, and then a nice little foot to kind of tie it all together and achieve the look that we were going for. And so that's a finished leg blank, and I did that with all 5 of the legs. Like I said, I made 5, so I would have one to test with. The 5th one I actually made out of red oak because I just had some extra red oak kicking around, and I don't know about you, but I don't like red oak as much as white oak, and it's quite a bit cheaper, so that was an easier thing to make a test piece out of. And then like I said, I fastened this down a little better because we were getting a little bit of movement in the base, and I didn't want anything to move around here because it would reflect in the actual part. So there's that tailstock I was talking about, and that's all it is. It's just a big piece of threaded rod, and I was able to put a nut on the front and back of that, and that kept the leg right in place. I put some Loctite on those little screws too, and I filed a flat on that piece too, just so that sprocket wouldn't move, because if that sprocket changes location, it's going to throw the whole thread pattern off. And on our first one, we started with this 3/4 inch round over, or bullnose bit, and we actually ended up we stepped it down to a 1/2 inch. So this first piece here is kind of our test piece. This is the red oak one. And kind of lining everything up, and now I was going to go and give it its first try. So I turned the router on, plunged it down maybe an 1/8 inch or so, and just ran it with a drill. And it actually was working really well. So we had some things to figure out with the red oak piece, but I figured I'd show the white oak ones when we kind of had the process figured out so I could demonstrate that a little better. So we would plunge in that cove bit and run that up the length, and I think it was 3 or 4 passes to get to full depth. So then I took this 1/4 inch roundover bit. It's just a cheap one from one of those router bit sets, and I ground the top off and made it into kind of that cove pattern because we wanted the threads to have a nice rounded feel all the way up. So by rounding the nose of that router bit off, it fits down into the cove cut by the box core bit. if you look at the threads now, they're square on top, and it looks almost like an Acme thread. And we want it to be really rounded off. So then I plunged this bit in and did the same thing, ran it up the leg in a couple passes, and you can see how that really changes the look. And the more passes we took, the more you get that fully rounded look. So it's rounded at the bottom and rounded at the top. And I had a little stop that I set up with a clamp so I would know where to stop and not run the router too far into that top bead. And that was working great. So I did that with all 4 of the legs, and it would make a lot of dust. So I would always, after each leg, I would empty it out. And then reset and start again. And I would do the same thing every leg. They were all pretty much the same, but I still wanted to check and make sure that I had a fresh starting point on each one. So I would remark each leg just to make sure everything checked out well. And this was kind of just a cool angle. You could see the router running up the distance of the piece. And so all in, it was probably 6 passes, 3 with the round over and 3 with the cove bit. And then there was still a lot of handwork after, just a lot of filing to take out any of the router marks and a ton of hand sanding. It was still probably a good 3 or 4 days at least of handwork alone to get these legs to where they were presentable and they didn't look like they had all these marks in it. So there you can see on the right there's some of the finished ones. And then this was the table, all complete. We did a parquet pattern on the top and we bleached it out, and it was really a really beautiful table. This is one of the favorite pieces that I've made, but I really wanted to highlight the legs and make a video demonstrating the kind of problem solving and just the process of how we made those spiral legs. So as always, thanks for watching.